Hello, everyone. We're working through an introduction to statistical methods and data analysis by Ott and Longnecker. We're on chapter 11. Okay, suppose that we have some future value of x. We could call this xn plus 1 or x new. And what we want to do is we want to make a confidence interval for a new prediction of y. So we can get our confidence interval by calculating y hat new or y hat n plus 1 and applying our confidence interval formula. We get two sides. We get y hat n plus 1 minus our critical value. Our degrees of freedom is n minus 2 because we have two parameters that we're estimating in our model, 1 over n plus xn plus 1 minus x bar squared over the x deviations. And then the upper value of our confidence interval, y hat n plus 1 plus t alpha over 2 n minus 2 s epsilon, or the square root of 1 over n plus xn plus 1 minus x bar squared over sxx. All right. Okay, so essentially what we're going to do is when we have our new value of x, we're going to first make a prediction for that new value of y. And we can think about the difference between a confidence interval and a prediction interval. Okay, so in our confidence interval, we're thinking about any value that could be predicted, but for values like that value. Whereas in a prediction interval, we're just thinking about one single prediction, right? So there's a difference here in the amount of variability that we might see in a single prediction versus a group of predictions at a certain spot. So our prediction interval, you can see over here that our standard error is slightly larger. So what we have is a very similar formula for the prediction interval, y hat n plus 1 minus t alpha over 2, degrees of freedom n minus 2, s epsilon square root. Now we have 1 plus 1 over n plus xn plus 1 minus x bar squared over the sum of the x deviations squared, and then y hat n plus 1 plus t alpha over 2 n minus 2 s epsilon square root 1 plus 1 over n plus xn plus 1 minus x bar squared over the sum of the x deviation squared. All right, so in one case, the confidence interval, we're thinking about what we might see if we had a group of predictions all at the same value, whereas a prediction interval is talking about just a single instance. So these intervals are slightly different, where the prediction interval is larger than the confidence interval. All right, in general, just remind yourself that both of the confidence intervals and the prediction interval width depends on your original sample size n, right? So if we increase our original sample size, we should decrease the width of both the confidence interval and the prediction intervals, because what this means is that we have more we have more information, which should make our estimates more precise. All right, in general, we can call this last piece, this xn plus 1 minus x bar over sxx, right? This is our extrapolation penalty. So what that means is that if our new observation of x is very close to the mean, right, and it's very close to the other x values, then we believe our estimates are going to be more precise. But If our new value of X is very far away from the mean, so it's more on the edges of the graph, then our estimates will be less precise because we probably have less data points on the edges compared to the middle. So that last piece we can call our extrapolation penalty. And then just as a reminder, since there's more variability in what we could see in a single observation versus a group of observations at a particular value, we should always see that our prediction interval for a new value of y is going to be wider than a confidence interval for the average value of y for a given x.